Hi, this is Sue McBride, and this PowerPoint will cover section 3.1, frequency tables from the text Statistical Reasoning for Everyday Life. In chapter 3, we're going to start using a little bit more technology to study our statistics. Our course objective for a good part of chapter 3 will be using visual and numeric information to describe, compare, and contrast univariate data sets. Univariate means it just comes from one variable. Our learning goal for this particular section 3.1 is to be able to create and interpret frequency tables. One of the things I'm going to ask you to do is to create them by hand and also create them using Excel. So you will want to have access to Excel program, and I will show you how to create it by following the directions in the book, or I made a little video. Alright, so let's get going here. First we need our definitions. So a frequency table is just what it sounds like. It has two columns. One column lists the categories of the data, and then the second one just has the frequency. Hence it's called a frequency table, which shows the number of data values. Now these are going to be discrete numbers, 1, 2, 3, 4, because we're counting. So a frequency table has categories and then the frequency, which are going to be discrete values. So for example, we have a taste test on a new product, Coral Cola, and set up a taste test where we have 20 people. So each individual is asked to test it and rate it on a 5-point scale. And here's the following results, but looking at it like this, it just doesn't make a lot of sense. So a frequency table helps to organize your data. When you see this chart, you go, oh, I understand exactly what happened. So my variable taste gives your categories. So I could have had a taste scale of either 1, 2, 3, 4, or 5. And then the second, excuse me, column has the frequency. So when I look at this, I know 2 people said they didn't like it that much. They gave it a taste test scale of 1. 3 people liked it okay, 9 were pretty good, 4 really liked it, and 2 loved it. So that's our rating, and it's beautifully organized. And notice the total at the bottom is 20. So every time you add up all the people that took the taste test or all the data, that total should add up to the sum of the frequencies there. This goes straight into what's called relative frequency. We're going to relate the individual amount to the total. So my relative frequency for any category is the proportion or percentage of the data values that fall in that particular category. So in your section notes, here's the formula I want you to write down. Relative frequency equals the frequency in any one category divided by the total frequency, which is that number. So in order to find the relative frequency, here we're doing grades. So there were 25 people in this class, 4 got A's, 7 B's, 9 C's, 3 D's, 2 F's. So if you wanted to know how did the people with A's, how did that number relate to the whole class, you would say 4 out of the 25 people, or 0.16. I could also convert that to a percent, but usually we give relative frequency in decimals. B is 7 out of 25 B's, or 0.28. My relative frequency of C's is 0.36, D's 0.12, and for F, when you divide the 2 by the 25, make sure you remember to include that 0.08. Now, if you sum that relative frequency, it has to add up to 1. Again, if I turn these to percents, then you would go, oh, that's 100% of my data. But we are leaving them in decimal. So we would say the total relative frequency would add up to 1 if I added up all the individuals. All right, now cumulative frequency we combine in a slightly different way. Cumulative frequency of any category is the number of data values in that category and all the preceding ones. So it's like a summing total, hence the word cumulative. I'm accumulating as I go the frequency. So here, if I looked at this, here's my grades of A through F again. Now my first row I start with a cumulative frequency in the first row. So if I ask how many A's did I have, it's just 4. If you're doing cumulative frequency, that's equivalent of saying for the second row, how many people got A's and B's? So I add the 7 and the 4 to get 11. My cumulative frequency for the row of C means how many people got A's and B's and C's. So we add those 3 up to get 20. D, I'm going to add up all the people who got A's and B's and C's and D's, give me a 23. And notice that last column, or sorry, row there, when I add those all up, I end up with 25. So when you're doing cumulative frequency, the final row should always be your total that you had, because that's the equivalent of asking how many people got an A and a B and a C and a D and an F, and I just add them all together. Now I made a little note at the bottom here in your guided section notes for chapter 3. If you kind of look down where it says applying knowledge, I'm going to be requiring you to make an Excel to create table 3.1 on 79. And in it, you're going to have something similar to this. You're going to have grades, you're going to have a frequency, and I'm also going to ask you to do the relative and cumulative frequency using Excel commands. So you'll see that shortly. Okay, as I said, I was misinterpreting what they were asking. The cumulative frequency showed that 14 out of 20 or 70% gave a rating of 3 or lower. That's what I went back to find. So I would just add up my 45, 15, and 10 to get that. So 14 out of the 25 is equivalent to 70%. So I could get the same. So that said, for the 30 stocks on the previous slide, shows the annual revenue in billions for the 1-year total return and the rank in the Fortune 500. So I want to create a frequency table and discuss the pros and cons of my binning choices. Alright, so my revenue data range from 21.6 billion to 351.1 billion. Wow, that's a lot of money. There are many ways to bin it. Here's one good way. We create bins that span from 0 to 400 billion. So that covers the whole range of the data with a little extra room. And we're going to learn when we do histograms that little bit of extra room for the highest and lowest really is essential. All right, so we give each bin a width of 50 billion, so we can span that over 8 bins. So the width of 50 billion is a nice convenient number, and it makes it easy to count. All right, also because those data values are given to the nearest tenth, we can define the bins to the nearest tenth so they don't overlap. So again, when we go to do histograms, this idea of not overlapping is going to be important. So we're just going to go use 50 billions. So 0 to 49.9, then notice if I have 50, I'll go into the next bin, etc. All right, so we've already talked about that a little bit. So when I bin data, we do that when it's impossible or impractical to have a category for every data value. You just got too many. So bins or classes is another way you see that when you're talking about histograms. Just gives a better way to organize. So if we talk about 3 different possible ways of binning the data in that last table, I could have 4 bins spanning the 0 to 400 billion, or I could have 11 spanning 0 to 375, or 36 going from 0 to 360. Each one of those has pros and cons. The pros is the more bins you have, gives you a little bit better spread of the data, but then you end up having too many. You've got too much, you really haven't categorized it well. You haven't given yourself an easy number to work with. So as the number of bins increases, the number in each one's going to decrease. Conversely, as the number of bins decrease, the number in them increases. So your particular project you're working on, whatever your statistical study, you kind of have to, there's no hard and fast rule. And in the notes, if you see the last little thing, it says the choice of bins is somewhat arbitrary and depends on the purpose, size, and spread of the data. So if you were doing a test, there was a 10-point scale, then that might be a good way to do it. Or I'm going to leave that at that. All right, so let's go ahead and look at examples from the text. Okay, I'm looking at page 82. We are going to need to do a little bit of math, so you want to have your calculator handy. All right, so first off, let's do some literacy definitions. So does this make sense or not? And explain why or why not. And not all the statements have definitive answers, but we want to take a look at them. So number 5 says you got a friend who tells you her frequency table has 2 columns labeled state and median income. Does that make sense? Well, no, because we know our frequency table has to have a category and then a frequency. She didn't say how many of either of the two. So a proper frequency table would be state and then the frequency of the state. And then if I wanted to do a separate one and do median income, that probably would do better with a bin, because the likelihood of somebody making exactly, $20,000 is small, but making between 15 and 25,000, that's a better way to do that. So that would be a good time to use a bin, would be on the median income, and the state really isn't a good choice because, yeah. All right, number 6, relative frequency of category A in a table is 0.27 or 27%. That makes sense because remember our relative frequencies have to be between 0 and 1, or if it's in percentage between 0 and 100. So that's fine. Now number 7 though, the cumulative frequency of a category is 25.5. That makes no sense at all because remember frequencies are discrete numbers, 1, 2, 3, 4, 5. I can't have a half of a frequency. So I have to have whole numbers as frequency. So that one does not make sense. All right, number 10, we were just to make a nice frequency table for the number of stars and the frequency at which they occur for San Francisco restaurants. So our category is the number of stars, and then my frequency is shown. All right, so I went ahead and set up the stars and the frequency. Now, how would I do the next ones? I wanted to talk that through. All right, so I'm going to get my calculator out. I don't have a place to actually write this, so we're going to go through it. So before I can do my relative frequency, I need to have my total. So I would just add up 2 plus 12 plus my 18 plus 6 plus 2. And I can't add today, so let's see, try that again. So 2 and 12 is 14 plus my 18 plus my 6 and 2 is 8. So it looks like I asked 40 people. And notice they didn't tell me in the original problem that I had 40. So I would double check that. So that's 8, 30, 40. Yep. So I had 40 people that were asked about, actually 40 restaurants that I looked at for how many stars they had. All right, so if I'm going to do a frequency table, I got it. Relative frequency now. The relative frequency of a 1 star would be 2 divided by 40. So n was 40. I want to write that down so I don't forget it. So number 10, n equals 40. Got it. N is your number of things that you were looking at. So 2 divided by 40. On your calculator, you should see 0.05. So that would be the relative frequency. If you wanted to turn that into a percent, it would be 5%. 12 divided by 40 would give me my relative frequency for 2 stars. So that's 0.3 or 30%. 18 divided by 40 is 0.45 or 45%. 6 divided by my 40 is 15% or 0.15. And then back to 2 divided by my 40 should give me the same thing as it did for a 1 star of 0.05 or 5%. So interesting that I have as many 1 star as 5 stars in San Francisco. All right, so that's my relative frequency. Now my cumulative frequency, remember I add as I go. So for the first row, my cumulative frequency would be 2. For my second row, my cumulative frequency would be a combination of the 1 and 2 stars. So that would be 14. My third row would be, and I just like to add them as I go. So 2 plus 18 gave me my, or sorry, clear. Try that again. 2 plus 12 gave you my 14. All right, so then I just hit plus 18, gives me 32 for my cumulative 3 stars. So that means I have 32 restaurants that either have a 1 or a 2 or 3 stars. Then I add 6 to that to get 38. So my cumulative total for 4 plus 3 plus 2 plus 1 stars is 38. And when I add that 2, I do get my 40 for my total of 1 through 5 stars. All right, so that all worked out nicely. All right, let's look over at number 16. Here we're missing some information, so we have to use the definitions to kind of work backwards. So the following table shows grades for performances in a drama class, with the categories being A, B, C, D, and F for grades. And then the table's incomplete, so I have to use a little bit of arithmetic in order to figure it out. All right, let's see. So if my cumulative frequency in the first row has to be the same for both, so I would have to replace that first question mark with a 1 for my frequency. All right, now I've got some scratch paper out, so I'm going to do it as I go. So frequency would, for the grade A, would have to be 1, and the cumulative frequency is also 1. All right, now I know for B, my next frequency was 6, so my total of A's and B's would be 1 plus 6, or 7, would go in the cumulative frequency. For C, they gave me a 7, so I already had 7 with the A's and the B's, so I'll add 7 more to get 14. So now I got to work backwards here. So for a grade of D, they told me there was 23. I had 23 minus the 14 I had when I started. So 23 minus my 14 gives me 9. So that means 9 people must have had D's, and 25 F's should be 2 then, because I had 23 plus 2 would give me 25. All right, now I have to double check. So when I add up my frequency column, 1A, 6 B's, 7 C's, 9 D's, and 2 F's, I better get 25 or I did something wrong. So let's double check it. 1 plus 6 plus 7 plus 9 plus 2 does indeed give me 25. So those are correct. All right, and then my last one, interpreting family data. All right, so watch how the question is worded here. When you have more than or less than, you're going to have an accumulation, but you have to look at what you're accumulating. It doesn't necessarily go in a cumulative frequency way. All right, so consider the following frequency table for the number of children in American families. So according to the data, how many families are there in America? All right, so to get that total, I'm going to add up the 35.54, so do it with me. Just adding on my calculator, 35.54 plus 14.32 plus 13.28 plus 5.13 plus 1.97. So when I hit enter, I get 70.24, and that's in millions. So my answer to part A would be 70.24 million people. All right, so part B, how many families have 2 or fewer children? So that means I'm going to add up the ones with 0, 1, or 2. So I'll add 35.54 plus 14.32 plus 13.28, because that's 2 or fewer, so I include the 2, and I'll get 63.14 million. So pause and add those up if you're not sure. All right, so what percentage of American families have no children? So to get my percentage, I have to divide. I need the number with no children, 35.54, but to get the percentage, I'm going to divide it by how many we said we had, which was 70.24. And I'm just going to leave this all in millions because the ratio works itself out. So 30.54 divided by my 70.24, and that gives me 0.5059. But notice they asked for it in percent. So look at your calculator. Go ahead and put this in. You get 505979 continued. If I want percent, I remember I talked about this on a prior PowerPoint, I have to move my decimal first, so that would be 50.5979%. So if I'm going to round that to the nearest tenth, I now keep my 50 point and it would be 6%. So don't round it first, you'll end up being off on your decimal places. All right, and last D, what percentage of American families have 3 or more? So I would add my 5.13 plus my 1.97. I'm just going to do this all on my calculator because I have to divide it in a second. 5.13 plus my 1.97. All right, so my total would be 7.1 million. But again, I was asked for percentage. If I have to divide that by my 70.24, and I get 0.10108. So because I've got to turn it into percent, that'd be 10.108%. So the nearest tenths, that would be 10.1%. Okay, so remember, part of your applying knowledge is to make that Excel spreadsheet, and you're going to cut and paste it right onto your section notes when you submit it. There's a little video to help you with that. If you're having trouble with the formulas, you can kind of see them at the bottom, but I always like to play around with my Excel, so I did you a little video. All right, thanks so much. Bye-bye.